Multiplication properties of exponents. Today we're going to use the multiplication properties of exponents to evaluate and simplify expressions. These properties that we're going to do today should be a refresher from last year. You have learned these rules in the past. We're going to take them, refresh them, and start to combine them together. First, a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. For example, the number 3 is a monomial. The letter x is a monomial. 3x is a monomial. 3x squared y are all monomials that are glued together by multiplication. First, product of a power. When you're multiplying powers with the same base, you're going to add the exponents and keep the base the same. So if you look at my first example, 6 to the 4th means I have 4 6s. 6 to the 8th means I have 8 6s. Well, how many do I have total? I have 4 plus 8, which gives me 12 6s, or 6 to the 12th power. Whether you're talking about numbers as your base or variables as your base, the rules are the same. So x cubed times x to the 5th is really x to the 8th. Here are some examples. 6 to the 6th power times 6 cubed. Well, the base is 6. It stays as a 6. Notice I'm not multiplying 6 times 6 to get 36 because there are 6 6s, 3 6s. There are a total of 9 6s, or 6 to the 9th power. Example 2. 2 to the 5th times 2 to the 1st. If there's no exponents, assumed to be the first power. That gives me 2 to the 6th power. N to the 5th times n to the 7th gives me n to the 12th. Notice with number 4 we have different bases. If you have different bases, whether they are numbers or variables, you cannot put these together using the rule. It is considered simplified. Now in life, could I do 3 squared times 5 squared, do 9 times 25 and get an answer? Absolutely. But when we're talking about the exponent rules, this is considered a simplified statement. Your job right now is to finish 5, 6, 7, and 8. Next rule, raising a power to a power. You're going to multiply the exponents and keep the base the same. So if you think about this, 8 cubed to the 6th power really is saying 8 cubed times 8 cubed times 8 cubed. I'm going to do this 6 times. And really this is the first rule. They're all the same bases, so you add the exponents, so you get 8 to the 18th power. The shortcut is when you have a power raised to a power, you're actually multiplying the exponents. So b to the 9 to the 4th power is really b to the 36th power. Example number 9. 5 to the 4th raised to the 2nd power. All you do is multiply the 4 times 2 and you get 5 to the 8th power. 6 to the 7th to the 9th power. Keep the base the same. 6 to the 63rd power. Negative 17 to the 2nd to the 1st is just negative 17 to the 2nd power. Notice I'm keeping my negative 17 in parentheses because when you do this problem it would be negative 17 times negative 17, which gives you a positive answer. If you have negative 17 squared without the parentheses, the only thing being squared is the 17, so it'd be 17 times 17, then you would have a negative answer. Go ahead and do 12 and 13. Number 14, when you have the quantity to the 3rd to the 5th power, you keep it as the quantity z plus 2 to the 15th power. And that's as far as you can go at this point. Number 15, we're mixing the rules together. Here we have our power to a power, so you get x to the 15th times x to the 4th, And now they have the same bases raised to an exponent, so I get x to the 19th by adding the exponents. This is where we're going to start to mix the rules together. Third rule, finding powers of products. A product raised to a power equals the power of each factor raised to that power. Well, for the first example, 2x to the third power is really 2x times 2x times 2x. Well, using my commutative property, can't I put all of my 2's together than all my x's? So I could really write this as 2 times 2 times 2 times x times x times x. Well, isn't this really 2 cubed times x cubed? Or simplified, 8x cubed? I don't go through all these steps. This is the logical progression of how I take my exponent and I give it to every piece or every term in the parentheses. It's sort of distributing, but it's not technically the distributive property because when you distribute, the terms are separated by addition or subtraction sign. So it's the idea of distribution. So let's look at the next example. This 4 has to be given to the x squared and it has to be given to the y cubed. Well, now it's just a power to a power. So x squared to the 4th is x to the 8th. Y cubed to the 4th is y to the 12th. Now, as we're adding on these rules, if you do not have them memorized from last year, these rules need to be ingrained into your brain. You have to get these rules so that you know them naturally. If you know them naturally, it'll be easier when we start combining the rules together. Number 16. Negative 2y, the quantity to the 4th power. So this exponent of 4 is going to go to the negative 2 and it's going to go to the y. So in this case, it's negative 2 to the 4th power, which ends up being a positive 16 y to the 4th. What's the difference between 16 and 17? Notice the negative sign is within the parentheses, so it was negative 2 being raised to the 4th power. Here, the negatives outside the parentheses, so the only thing being raised to the 4th power is the 2, which does give you the 16 y to the 4th, but that negative out front, it's like multiplying by negative 1, so you get negative 16 y to the 4th. Number 18. X to the 6, y cubed, the quantity squared. You give it to each term. X to the 12th, y to the 6th. Now when you get down to number 19, there's two different parts. I would simplify this, I'd simplify this part, and then I would combine the two together. So doing that, I get x to the 8th, y to the 12th, times x to the 8th, y to the 16th. Well, now I combine like terms. You put your x's together and you get x to the 16th, y to the 28th. Go ahead and try number 20 and number 21. Number 22. In 2003, the U.S. Department of Agriculture, USDA, collected data on about 10 to the 3rd honeybee colonies. There are about 10 to the 4th bees in an average colony during honey production season. About how many bees were in the USDA study? Go ahead and figure that out. Same with number 23. A box of staples contains 10 to the 4th staples. How many staples do 10 to the squared boxes contain? Figure that answer. Bring everything to class. We'll go over it tomorrow.